We are going to consider elasticity, which at its most fundamental is a way to measure responsiveness in the market. We've looked at the market, that is the supply and the demand of things, and we've seen how that market can change. When income goes up, demand increases, prices go up, and equilibrium quantity increases, or technology changes, and that impacts the supply side of the market. What elasticity allows us to do is to answer the question of how much. It's a way for us to measure how responsive different aspects of the market are. When income goes up, just how much of an impact does it have on demand? When technology increases, just how much of an impact does it have on supply? These are the sorts of things that elasticity can do for us. We're going to start with the own price elasticity of demand. To motivate this, we've got two different demand curves here. These are both totally valid demand curves, I want to point out, but they look very different, right? This one on the left, very, very steep curve. Notice there's this very, very big change in price, but if we considered two different points along this demand curve, there's definitely this inverse relationship. When prices go up, quantity demanded is going to fall. This demand curve on the right, also equally valid, showing this inverse relationship. If prices go up, quantity demanded is going to fall. If prices go down, quantity demanded is going to increase. But, right, very small change in price, very large change in quantity demanded, very large change in price, very small change in quantity demanded. I challenge you now to sit back and think for a second about different things that you're used to purchasing that might fit these two different pictures of demand. But at the heart of it, both are equally valid. We can formally do a couple of things with an elasticity. We first want to make a definition of elasticity. So we have this definition or this formula for the own price elasticity of demand. I'm going to follow our text for this class so that we're all on the same page. Their notation of what they use is capital E for elasticity and lowercase d for, or the subscript d for the own price elasticity of demand. Right? If you recall, I've got the two lines on the outside representing the absolute value. So that means I'm making all my numbers positive. If they're positive, I keep them positive. If they're negative, I convert them to the positive value. And it's just simply the ratio of two things. In the numerator, I've got the percentage change in the quantity demanded. And if you recall, we reviewed how to calculate a percentage change. In the denominator, we've got the percentage change in the price. Right? So we do this calculation, we calculate these two percentage changes, take the ratio of two percentage changes, then take the absolute value of that number that we end up with, and that value that we're left with could range anywhere from 0 all the way up to positive infinity, right? It can be any non-negative number. It can't be the negative ones because we've got the absolute value here, right? But it could be as low as 0, could be as high as infinity. For us, when we get that value, the number that's important to us in terms of figuring out how we classify a good according to its own price elasticity of demand is the number 1. If the number you get, if the value of elasticity is less than 1, we say that a good is inelastic, or more formally, we say that the demand for the good is price inelastic. If the number that we get is greater than 1, then the term we use for that is elastic. We say that the demand for the good is price elastic, or the own price elasticity of demand is elastic. Inelastic, elastic, our tipping point is whether it's less than 1 or greater than 1. A very less interesting case is if it's equal to 1, the formal term for that is unit elastic, and we almost never see that when we're actually estimating goods and services. So that's why I think it's not that interesting. This is the formal terminology that we want to use, inelastic and elastic, but conceptually, a nice way to think about it is in terms of responsiveness. So again, these are not the formal terms, but these are the ways a way that's useful to think about it. If you've got an own price elasticity of demand that's less than 1, it is inelastic, but you really want to think about that as, oh gosh, that's a good that's not very responsive. It's very unresponsive. Whereas if you have an own price elasticity of demand that's greater than 1, yes, it's elastic, but you also want to think of that as, wow, that's a really, really responsive good. We can use a little bit of algebra to get a little bit more intuition with that definition and those classification systems. We just established that the own price elasticity of demand, if it's less than 1, we classify it as inelastic. So if we have an inelastic good, then that means that, again, just substituting in our formula, that the absolute value of the percentage change of the quantity demanded divided by the percentage change in the price is less than 1. Well, with a little bit of algebra, I can break this apart, multiply both sides of my equation by the absolute value of the percentage change in P, and what I'm going to be left with is this right here. That is to say that the size of the change in my price is greater than the size in the change in quantity demanded. That's the case for inelastic goods. And if we look down here, isn't that exactly what this steep demand curve is telling me? I've got my change in price, very, very, very large change in price, small change in quantity demanded. Those are my inelastic goods. Think of goods that you buy where even if the price were to spike way, way, way up, what are some goods that you don't really cut your consumption out that much? Those goods where when price changes, the quantity demanded does not respond that much to changes in price are those goods that we refer to as inelastic. Elastic goods are the exact opposite case of this, right? So again, if it's greater than 1, then our term is it's an elastic good. If it's greater than 1, substituting in the formula, greater than 1, and again, breaking this apart and multiplying both sides by the percentage change in the price, we've got this story for our elastic goods. That is that the size of the change in quantity demanded is greater than the size of the change of the price. That's for our elastic goods. And that's exactly what these flat demand curves are showing us, right? The size of the change in price, very, very small. But gosh, how big of a reaction was there in terms of quantity demanded, in terms of how many units the market wanted to buy. Can you think of a good where, geez, if the price goes up just a smidge, a whole bunch of customers flee the market and probably go and spend their money on something else? Or similarly, can you think of something that, geez, if it just goes down by a very small amount, suddenly a whole bunch of people jump on board and want to buy that good instead of something else? Those are our elastic goods. We can go through a couple of examples. We've got things like tobacco and electricity. Those are inelastic goods. And restaurant meals, green peas, those are things that are elastic, right? Again, my thing with my elasticities, my point of reference is 1. Is it less than 1, greater than 1? That tells me whether it's elastic or inelastic. Fundamentally, what are the things that determine whether a good is elastic and inelastic? Number 1, number of substitutes. And we generally have this rule that the more substitutes there are for a good, that tends to make a good more elastic. That is to say, the more substitutes that a good has, the more responsive people will be to a change in price. Think of it in the other direction. If you don't have very many substitutes, if the price goes up, what do you do if there's not substitutes? You're kind of stuck paying for it. Maybe you'll try to cut your consumption a little bit, but if you don't have something else that you can substitute to, you're not going to respond that much. Few substitutes, inelastic; many substitutes, elastic. Also, whether something is a luxury or a necessity, with the idea that the more that something is a luxury, the more elastic its demand is. By market definition, we really mean, what's the good that we're talking about? How are we defining our market? We can think of, are we thinking of the market for breakfast cereals, or are we thinking of the market for specifically Count Chocula? Think about how when prices go up, the more narrow our market definition, the more elastic the demand for that product will be. With time horizon, that's how much planning you have. The more planning you have in general, the more elastic the demand for a product will be. The more short-term our product is, the shorter our time horizon, in essence, you don't have as many substitutes if you don't have as much time. Makes sense that that's a more inelastic measure. And this last category, importance to budget, that's a debated one between economists, but some people make the argument that the smaller the importance in the budget, what do you think that makes it, more elastic or inelastic? Lastly, we've got 2 other extremes that we can consider real quickly. We said that if it's less than 1, it's an inelastic good. Well, what if it's the smallest number possible? And we said that's 0. We refer to goods that have an own price elasticity of demand equal to 0 as being perfectly inelastic, and this is what the graph of those look like, a perfectly vertical line. And you can think about, gosh, no matter what the price, The amount that people want is not going to change. Even if price were to change wildly, the amount of quantity demanded would not respond. At the other extreme, anything greater than 1 is elastic, could be all the way up to infinity. If we have our own price elasticity of demand equal to infinity, we call those perfectly elastic, and that's a perfectly flat line. And you could think about, geez, any small change in price and all customers are just going to completely leave the market. Perfectly elastic goods, those are goods that have many substitutes. So you can think about the corn that a single farmer sells. That has perfect substitutes from the corn from all other corn that other farmers sell, right? Nobody has any preference for individual corn from an individual farmer. For the most part, that's the way the market responds. And so we can think about, if there's infinite number of substitutes, then we're going to have perfectly elastic and this flat demand.